Okay, in our last lesson, we're revising the consolidation exercise. Am I right?
Yeah, yeah.
Yeah. So we're just gonna continue with that. Gonna continue with this. I think we've gone as far as number 5. Am I right? Was it number 5?
I think so. Let me check.
Okay. Let me just check here. Yeah, we're here number 5. We did number 5, I think. We did number 5. We're done with number 5. Oh, it was 5. No, we're not done with number 5.
For the consolidation exercise.
Come again?
For the consolidation exercise.
Yeah, it's the consolidation exercise, yes.
The electromagnetic radiation one.
No, the one for physical and chemical change.
Ah.
Physical and chemical change. All right, we're doing this one here. This one, particles of which substances are made and physical and chemical change. Ne? Right. So we had gone as far as 5.5.2. That's where we were. All right. So I'm just going to continue with 5.5. I did 5.5.1 and 5.5.2. It was just the balancing. A balanced chemical equation showing all the phases and reactants and products. So for 5.5, there it is there, 5.5.2. Right. I'm not sure if it's okay. All right. So we're showing this one here. You have to write an equation here. All right. You have iron plus oxygen to give you iron 3 oxide. All right. So they want a balanced equation. So iron, that's your Fe, and oxygen, that's your O2. And now the challenge comes here, where you've got iron 3 oxide. You have to write the correct formula here according to the crisscross. So here iron, the 3 Roman numerals tells you it's Fe3 plus, right? Let me just see if I can open. Okay, let me just see if I can open and try and write here. It's iron oxide. Let me see here. The whiteboard, let me see. Just try and open the whiteboard here. Okay, so you've got your Fe3, your Fe, it's 3 plus, and it's bonding with oxygen. So your oxygen, it's O2 minus. So you look at the charge here. The charge here is 3, right? And the charge here is 2. So you do crisscross here. You do your crisscross. So your formula is gonna be, Fe, Fe2, and you've got your O3. That's the formula for iron 3 oxide. That's how you do it. So it's Fe3, you do that. Can you see that? Hello? Are you clear here?
Yeah.
Okay, right. So this is your formula for iron 3 oxide. Then we go to that question that we're dealing with. All right. Okay, there we are. All right, so that's what you have here. So your formula here is going to be Fe, then you've got your O2, and you've got your Fe 2O3. Then your answer should look like this. There's your final answer there. Then on your answer, you have to balance it. So iron is going to be 2 iron there, all right? Then actually here, iron is going to be 4. Then your oxygen here is going to be 3, and your iron oxide is going to be that one. Are you okay with the balancing?
Yes.
Or should I do it? Hello?
Yes.
I must do the balancing. Are you fine?
Yes.
Okay, all right. So we move on to 5.6.1. 5.6.1, what does it say? It says a 20-gram sample of calcium carbonate in process Y decomposes to form 11.2 grams of calcium carbonate, calcium oxide. So 20 grams of calcium carbonate in process Y decomposed to form 11.2 grams of calcium oxide. In a second sample, you've got 30 grams decomposed to form X grams of carbon dioxide. Right? State the law of constant composition. All right. So law of constant composition. What do you have? Right, you've got states that no matter how a chemical compound is prepared, it always contains the same elements in the same ratio, in the same proportion to the mass. Same proportion of the masses, right? So here we need the law of constant composition, right? Constant composition. So that's the ratio. The one that we spoke about water, the ratio is always 2:1. If it's hydrogen peroxide, it's always 2:2. So that's what we are talking about. Then the second one, use the law in question 5.6.1 to calculate mass X of the carbon dioxide that is formed. All right, so let's look at the solution here. Option 1. All right, so initially here, what do we have here? We've got 20-gram sample of calcium carbonate. All right, it breaks down to 11.2 calcium oxide. All right, in a second sample, 30 grams decomposes to form X grams of carbon dioxide. So here, we need to find the one for calcium oxide. So because when you check on the formula, you've got calcium carbonate decomposes into calcium oxide and carbon dioxide. But the mass for carbon dioxide we don't have. We have the initial here, and we have the calcium oxide. We don't have calcium, we don't have carbon dioxide. So we have to subtract for us to get the mass for carbon dioxide. So that's what is shown here on the question, on the answer. So you have to say mass of, for you to get mass of carbon dioxide in the first sample, you have to subtract 20 minus 11.2, which gives you 8.8. Right, proportion of calcium carbonate in the first sample here, that's your 8.8 over the initial, which is 20. Right, then the mass of carbon dioxide in the second sample. On the second sample, what were we given here? We're told that in the second sample, 30 grams decomposes to form X carbon dioxide. So we have the initial of calcium carbonate, but we don't know calcium oxide. And we also do not know the mass of carbon dioxide. So what do? We have to use some proportion here, right? So what are we going to say? We're going to say the ratio of carbon dioxide to the total, it's 8.8 over 20 multiplied by the 30 for the second sample. So you're going to use a ratio here for you to get the mass, which becomes 13.2 grams. Is that clear?
Yes.
So you're using proportion for you to be able to get this. Is that clear?
Yes.
Right, then the other one, another option here, there are a couple of options that you can do this. You can say 100 grams of calcium carbonate. These are the masses. This is the mass for calcium carbonate. You get it from the periodic table where you've got calcium 40, your carbon there, it's 12, then your oxygen, it's 16 times 3, which is 48. So 40 plus 12 plus 48 gives you this 100 grams. You are using the periodic table. Then carbon dioxide, you've got your 12 plus your 16 times 2. So it's 32 plus 12, which gives you 44 from the molar mass of these substances here. So calcium carbonate, you started with 30 calcium carbonate and you're looking for X, so you can use proportion without using what was given for the first sample. So you can just do proportion here. 100 is to 44, 30 is to smaller than, so you're going to have to divide. What are you going to divide? It's going to be 44 over 100 multiplied by 30 to give you X is equal to 13.2 grams. Clear?
Yes.
Right, or you can use the proportion of the first sample, then you still get that, which is almost the same as the other one, then you subtract then. But you stick with the one that is easy for you. These are just options for different approaches. Right, any questions so far?
No.
Okay, we move on to number 10. We move on to number 6. It says magnesium ribbon burns in oxygen with a bright white flame to produce a white solid, magnesium oxide. All right. Name the type of chemical bonding in magnesium ribbon. So magnesium ribbon is a metal. All right. So what chemical bonding do we have in there? Yes. It's a metal, so we expect it to be metallic bonding. We expect it to be metallic bonding because magnesium is a metal, right? So we'll have metallic bonding. Next one, we've got magnesium oxide. So magnesium is a metal. Oxide means there is oxygen, and oxygen is a non-metal. So we've got a metal and a non-metal. So we expect this to be ionic bonding. So it's an ionic bond. Clear? Right,
Yes.
then we move on to the next one. 6.2, is the reaction between magnesium ribbon and oxygen a physical or a chemical change? Give a reason for your answer. All right, what do you say, Young? Is it physical or chemical?
Chemicals.
It's a chemical change, correct? Right. What is the reason? A new substance is produced, which is the what are we forming here? Calcium. We have magnesium oxide, right? So a new substance is being formed. Therefore, that one is a chemical change. Clear?
Yeah.
Right.
Yes.
Then we move on to the next one, 6.3. 6.3. We have write down a balanced equation for the reaction between magnesium and oxygen. Magnesium and oxygen. So you're gonna go here, right? You've got your magnesium plus oxygen O2 to give you MgO, right? Magnesium oxide. Then you need to balance it, right? Oxygen here, there are 2, but here there is 1 here. So you have to put a 2 in front of MgO to balance the oxygens. Right? By putting 2 here, you are disturbing the magnesium. You have to put another 2 there. So it's 3 marks. What is the 3 marks for? Writing the correct formula for your reactants, which is Mg and O2, 1 mark. And writing the correct formula for magnesium oxide, which is 1 mark. Then to put the 2's here for balancing, you get another mark. Clear? Right,
Yes.
then you won't be penalized if you use 2 arrows there. So it's gonna be 3 marks for that one. Right, we'll move on to the next one. 6.4, use the law of conservation of mass to show that mass is conserved during the reaction in 6.3. So we need the conservation of mass. Conservation of mass. So what are you gonna do here? You have to calculate the mass for the reactants and the mass for the product. So what are you gonna do? You're going to calculate the mass of the two magnesiums here. So here you have to use the magnesium. You have to use the magnesium. So you're going to say 24 from the periodic table, mass of magnesium multiplied by 2 plus, right? You've got to oxygen is 16 and there are 2. So it's 2 times 16. You add the 2, you get your answer 80. 2 times 24, that's 48. 2 times 16, that's 32. So 32 plus 48 gives you 80 grams. Then you go to the right-hand side. You're going to have your magnesium is 16 plus your oxygen, right? Plus your oxygen there. Oxygen is 16, sorry, and magnesium is 24. So you're going to add the 2. 16 plus 24, that gives you 40. 40 times 2, it gives you 80. So both sides have got the same answer. You're getting the same mass.
So,
So mass is conserved. Yes.
so isn't the equation the solution wrong because
I didn't get that. Yes.
okay, never mind.
Yes.
Sir. Never
Uh,
mind.
okay. All right. So here, the marking criteria here, you're going to get a mark. You're going to get a mark for 1 mark correctly calculated for the magnesium, 1 mark for calculating the mass of oxygen, then 1 mark for calculating the mass of magnesium oxide, then the comment to say the mass of the reactant is equal to the mass of the product. You need that comment there to show that mass is conserved, then you get your 4 marks. Right, then we go to number 7. Right, number 7 says, what is meant by the term allotrope or allotropes? Right, what is an allotrope? An allotrope, these are different physical forms of the same element. Like you've got diamond and you've got graphite. They're all made up of carbon, but they've got different forms, right? And different properties as well. So that's an allotrope. Right, we move on to the next one. The table below gives some properties of substances A to D. Right, so you've got substance A, minus 75 melting point, hard or soft, is a gas. Is it a conductor of electricity? No. B, 1538, that's the melting point. It's hard, it's a good conductor of electricity. Then C, you've got 1710, right, melting point. It's hard, right, and it's a non-conductor of electricity. Then D, we have got 1087, it's hard, conducts when molten, right? That is when it's a liquid, right? So match the letters A to D to the following substances, right? So we start here, we check here, we've got lead sulfate, lead and sulfate. Lead is a metal and sulfate is these are ions here. So this is an ionic compound, this one. Right, you've got sulfur dioxide. Sulfur dioxide, sulfur is a non-metal, oxygen non-metal. So this is a covalent molecule here, right? Because it's a metal, we've got non-metals. Then we've got silicon dioxide, right? So we've got silicon there, which is also a non-metal, and we've got oxygen, which is also a non-metal here. Right, then we've got iron, which is a metal. So we must check here. Which one? Iron, a good conductor of electricity. That should be a metal because metals are good conductors of electricity. So B must be a metal, right? Then we check again. There is a gas here. And a gas is normally non-metals. So it's most likely to be sulfur dioxide here, right? So we have, at least we've found A and B, right? Then we come to this, D. D says conduct when molten. So it means this one must be an ionic compound because we remember with salt. For example, salt, we have got sodium chloride. When you melt it, the salt, when you melt it, then it conducts electricity. But as a solid, it doesn't. So this should likely to be the ionic compound, which is lead sulfate, that one there. Right, then obviously the other one there becomes your last one, which is your silicon dioxide. Let's check on the solution and see what we have there. So we have substance A as a low melting point, which indicates weak forces, intermolecular forces. So A must be a covalent molecular substance. It must be sulfur dioxide. It is also the only gas out of the 4 substances. So A is your sulfur dioxide. Then substance B has a high melting point and it is hard. So it has a strong interparticle force, right? It can either be either a covalent network substance or an ionic substance or a metal. The fact that it conducts electricity in the solid state means that B is a metal, so therefore B becomes ion. Then you've got substance C. So for substance C, it is a high melting point. C is a high melting point. It is hard and it is a non-conductor. So here we have substance C as a high melting point. It is hard, so it is a strong interparticle force. It can either be a covalent network substance or an ionic substance or a metal. The fact that it does not conduct electricity means it's a covalent network structure. Therefore, C becomes your silicon dioxide. Then we go to substance D. It's your lead sulfate. The reason, other than the fact that it's the only one left, is that it is a high melting point. It is hard and conducts electricity when it's a liquid or when it's in a molten state. Because it conducts when it's in molten, then it means it's an ionic substance. So D becomes lead sulfate. Questions? Yes, Tolomzi, we see you there.
Yes, Mania.
Right. Okay, we move on to question number 8. Number 8, we have studied the diagram below showing structures of 2 different substances. We've got A and B, and answer the questions that follow. So we've got your A, it has got electrons in between. Already you can see that this substance is a metal because it has delocalized electrons here between the positive kernels. Then substance B, they are positive and negative alternating there. So it means this one is an ionic substance, right? So 8.1, choose the substance A or B that describes the following: metallic structure. So obviously your answer is A, all right? Then 8.1.2, structure of magnesium chloride. Structure of magnesium chloride. So here on the solution, you have to write A and B. So we expect you to write a B in terms of the just 1 mark. So it's B the answer. Why? Because magnesium chloride is an ionic compound. Magnesium is a metal, and that one is a non-metal, positive and negative. 8.2, explain how the type of bond in substance A forms. So they want you to explain how does a metallic bond form. All right, so there we are. It is formed when a pool of delocalized electrons surround the positive. There's a P missing here. Positive metal ion core. All right. So it's formed when we've got delocalized electrons surrounding the positive kernels. Right. That's how we explain it. As long as we've got those 2 points, you can always add more detail to that. But those are the main points for 2 marks. Next one, 8.3. Name the type of bond that exists in substance B. So substance B, these are ions. So this becomes an ionic bond. So the answer here is ionic bond. Right, we move on to 8.4.1. 8.4.1. Right, it says magnesium and chlorine react to form compound magnesium chloride. 8.4.1, define the term compound. Right, so compound, what is a compound? It's a pure substance consisting of 2 or more different elements. Right, that's the definition of a compound. Pure substance consisting of 2 or more different elements. Right, next one, 8.4.2. Write down the name of the group to which magnesium belongs. Write down the name of which the group of the group which magnesium belongs to, the name of the group. So if you go to your periodic table, let me just check here. The periodic table, this is paper 2, so I don't have the periodic table here. But your magnesium is in group 2, so it becomes
2.
earth metals, alkali earth metals. That's group 2. All right. Then we move on to 8.4.3.
So isn't it alkaline?
Huh?
Isn't it alkaline earth metals?
What is group 1? What about group 1? What is group 1?
Alkaline metals.
Yeah, so magnesium is in group 2, so it's alkali. Not alkaline, it's alkali metals. Do you agree, Joshua?
Not
He has to,
sure.
Huh?
he has to agree.
Remember, there's group 1, then there's group 2. So magnesium is in group 2, so it's alkali. The other one is alkaline. There's a difference there between the two. Just double check that one, then we'll verify that. But that should be the correct one. Okay, we move on to the next one. Write down the valency
It
of
says
a...
alkaline. It
Come
says
again?
alkaline metals are in group 1.
Alkaline metals.
Alkaline.
Alkaline, yeah, it's group 1. So group 2
So
becomes
alkaline is
So
alkaline is in group 2.
alkali, yeah, alkali, earth metals. That becomes group
So
2.
is it alkali or alkaline?
No, there's alkaline and there's alkali.
Yes, so I'm stating that alkaline earth metals is in group 2.
Yeah.
Alkali earth metals group 2, which is correct, right?
No, sir.
Alkali 1. Eish.
Alkaline.
Group 2 is what? Alkaline.
Yes.
And group 1?
Alkali.
Alkali. Okay, I'll double check that one. I'll check that one, then I'll come back to you. Maybe we could be confusing it as well. Okay, I'll come back to that one. I think in our next lesson, I'll check that one. Okay, let's look at this one. 8.4.3. Write down the valency of a chlorine atom. Right, valency, that's with a Y. Valency. What is valency, by the way? Valency?
The number of electrons needed to create a full shell or become a normal gas.
Right, or the number of unpaired electrons. So chlorine has got only one unpaired electron, right? So the answer there is 1. The answer is 1, right? So you've got 1 because chlorine has got only one unpaired electron, or it needs only one electron to fill its outermost shell. But valence without a Y, the answer would be 7. But here the answer is it's 1. Okay, we move on to the last one. Last one says use Lewis dot diagram to show the formation of magnesium chloride. Magnesium chloride, which is an ion. So here magnesium is going to donate electrons to chlorine. So what are you going to have? You're going to have your solutions. Okay, you've got magnesium. There's someone who's writing here. Please rub this. Okay, we've got magnesium. Magnesium, it's in group 2, so there are 2 electrons. Plus the chlorine. Chlorine has got, it's supposed to have another electron here, right? Or magnesium is going to donate the electron to chlorine, then the chlorine becomes a chloride ion, and you see something like this here, right? So magnesium loses 2 electrons to form Mg2+, and those 2 electrons are going to be, each circle here is going to be donated to the chlorine to form the chloride ion, and we have a 2 there, meaning magnesium is going to donate to 2 chlorine atoms. Then this is what we have. Then you're going to have your MgCl2 there. Right, so for 3 marks. How do you mark this? It's 1 mark for the Mg with those 2 electrons, and you've got your chlorine, the correct Lewis diagram there, 7 electrons, and then 1 mark for the right-hand side when magnesium becomes 2 plus and the chloride ions with showing the electrons and the charge there. Right, that's what you get there. So this is how you're supposed to have attempted the consolidation exercise.
See.
Yeah.
So
Yes.
what if you drew 2 CLs? 2 CL8.
You drew 2 CLs.
Yeah. Instead of like put a 2 in front of 1, I drew
Yeah.
like 2 separate.
2 separate. It's fine. It's still fine.
Okay.
Where? Here. On the left or on the right?
On the right.
On the right. No, it's fine. No problem.
Okay.
It's, that 2, that 2 just symbolizes that these 2 are supposed to, the chloride ions are supposed to be 2, but you can still draw the 2 of them. Is still fine. Clear?
Yes. So are you gonna post these corrections on Google Classroom?
I'm gonna do that. I'm gonna do that. I didn't post this, ne?
Yes, you didn't.
Okay, I'll post it. I'll post it soon after this lesson. I'll post it. We've got about.
So what are you doing with the videos? You're busy recording, right? Where's the videos going?
Where's that?
Videos that you're recording right now going?
For proof.
Okay. What I'm recording here, I didn't post it. I have it. I'm gonna post it. Where can I post it? You want to put it on WhatsApp or you want it on the Google Classroom?
Say,
Huh?
it's better we make a WhatsApp group than this Google
There's
thing.
already a WhatsApp group.
Yeah, there's one group. You must just tell who's this one. Joshua to add you. Joshua, just add Solomzi there. Do you have
Yeah.
his numbers?
Yeah, he has. He likes texting me, this guy.
Okay. All right. So let him add you to that. Then I'm gonna post the recording. I'm not sure whether they are videos. This one. They should be voice or something. I'll check. Oh, I have both of them. I think I'll check again. Right.
All right, man.
Right. Okay. Then there's one more thing. We've got about 6 minutes. We're gonna meet still on Monday, same time at 11. I think the attendance today is improved. Please join so that you understand. You have where you have questions, then we clarify. Ne?
Yes, sir. Yes, sir. Yes, sir.
Right. Then we've got there was exercise 11. I just want to quickly go over some of the questions there. Number A, it says a bar magnet. Let me just check. Right, it says a bar magnet is divided into 2 pieces. Right, this is the one that I posted the last one to post. Right, next week we're gonna move on to electrostatics. So I'm gonna do that, prepare that handout and post it maybe tomorrow. Then on Monday we'll look at electrostatics. So for now, I just want to go over this. It says a bar magnet is divided into 2 pieces. Which one of the following statements is true? The bar magnet is demagnetized. The magnetic field of each separated piece becomes stronger. The magnetic poles are separated. 2 new bar magnets are created. Right. So the correct answer there is D. When a magnet is cut into 2 pieces, 2 new bar magnets are created, each with their own north and south poles. So that's your answer for number 1. Then number 2, please check. There was a mistake there. I didn't put the options, but I've added the options now. So it says a bar magnet is divided into 2 pieces shown in the diagram alongside. Let me just mute everyone here. There's some noise coming through. Okay, right. Which of the following statements is true about the force between the broken pieces if they face each other with a small separation? Right. So A, no longer magnetic since it is broken. Neutral because the domains are disrupted. Repulsion, since poles are the same. Attraction, because the poles are opposite. So the answer there is D, right? So when it breaks, we're going to have your north, south, north, south. So north, here where there's north, actually there are two, there's a north and a south. So there's a domain, the north and south. Here where there's south, there's a north up here. So you're still going to have your north, south, north, south. So there will be attraction between the two. So the answer is D. Right, then the next one, 3.1. Describe what is meant by a magnetic field. So a magnetic field, it's a region in which a magnetic or ferromagnetic material experiences a magnetic force. Right, then draw a neat sketch of the magnetic field around a bar magnet. Right, so you're going to have that one there. Right, so you're going to have your north and your south. Then your field lines, these field lines are wrong here. It's supposed to be from north to south. So I will correct this one here. I must change this. This north is supposed to be here, and south, because field lines, they move from north to south. I'll rectify that one. Right, but your structure must just look like that. Please avoid where lines are touching here. You must avoid this. This diagram, there are a couple of mistakes here. So it's the poles are incorrect, as well as the touching of the lines there. It's not right. Right, then we move on to the next one. It says, describe what is meant by the north pole of a magnet. Describe what is meant by the north pole of a magnet. Right, so here, the north pole of a magnet is the place on the magnet where the field is strongest. And if the magnet is able to rotate, it will point this north-seeking pole towards the Earth's magnetic north pole. Here you can have different explanation as to what is the north pole. Someone can say it's where the magnetic field move from, or the magnetic field point away from towards the south. There could be different ways of describing the north pole of a magnet. Right. Then the next one, give 2 ways in which magnets should be stored so that they retain their magnetism for as long as possible. Right. For you to store magnets, this is what you need to do. Magnets are stored by placing them in pairs with their north and the south poles adjacent to each other. 2 pieces of soft iron called keepers are placed at each of the poles. Right, so you're going to have your keepers. Those are your keepers there. Those are your keepers. Magnets should be stored away from electric currents. So that's another way. That's another point that you can add, that keep them away from electric currents, because where there's current, magnets also wire carrying current has got a magnetic field, so it tends to interact with the magnetic field there. Magnets should be stored at room temperature. So those are some of, any one of those, then you get a mark. Then the last one, we've got 1 minute left. The last one says, what is meant by ferromagnetic materials? Give examples of 3 elements which are ferromagnetic. Right, so you've got your ferromagnetic substances which exhibit strong magnetism in the same direction of the field when a magnetic field. So these are substances that are attracted by a magnet. Right, example is your iron, nickel, chromium. Those are your ferromagnetic elements. Right, we'll continue from here on Monday. Please, same time on Monday. Thank you for attending. Hope you have a nice weekend.
Thank you, sir.
Okay, all right. See you on Monday. Thank you. Bye.
Wait, please support my business
Keep us
in here.
awake.
I have a business now. I
Yeah.
have a business now. Support.
What are you selling?
I'm selling Herbalife.
Herbalife. Okay. Now,
Yeah.
how do we'll support you when you open school?
I say I want a match.
All right. Sure.